Hey guys, it's Vince. Today in this video we're going to be taking a forensic look at a Chinese system that was retrofitted with a new integrated driver. And the reason I'm doing this video is I had a very interesting question come from a potential client. They were doing their pricing strategy as far as due diligence, researching components and systems, and they wanted a specific system built. I gave them a quote. They found this system and then used it or tried to use it as leverage against my system in terms of why my system was priced so much more when this system seemed to come with so much more for its value. Well, looking at this happens quite frequently. And I'm glad that this potential client actually went through, sent me the listing, and it's actually a listing on eBay. Now, of course, I'm not going to disclose who the actual seller is, but we are going to take a look at this because this is interesting in a lot of formats. I get this question a lot. Can I buy a Chinese controller, retrofit it, change things, manipulate it to give me a more stable system? And of course, the answer is yes, if you're willing to do it correctly and go through, again, the proper venue in which to achieve that. But we're going to go through this system. We're going to go through a couple things that I found, and we're going to go through why this system ultimately I would not recommend, and I do believe there's going to be stability issues down the road for whoever purchases this. And I'm going to explain why, and I'm going to show you validated proof of what I'm saying. So what we've got here is just some pictures of the system. You can see the front here. Many of you are familiar with these systems. This particular unit says SX CNC. They're no different than you've seen on numerous 6040 Chinese chassis, 3040s, 6090s. It goes on and on. You got the integrated VFD digital interface. They try to make it look very neat. You got your pump, your VFD switch, and your power switch, along with your e-stop. If we come to the rear of the system, I want you guys to pay attention. Of course, we got GX16s here. For each axis plug, he's got 5 pins. And the reason he has 5 pins, of course, is the 5th pin, I'm assuming, he is associating with a ground for your shielded cables. And I'll show you why I'm coming up with this as we go through this. But I really want to draw your attention to the parallel port, or where it says parallel port. You can see here we have a USB port. We also have 3 LEDs. And we have this filler plug that was apparently modified and put in here. Well, as we come through the system, we'll just go through it. Here is the board he chose to retrofit the system with. It's an integrated controller. It uses USB format. And the interesting part of this is he decided to use the GX16 5 pins up here, and he explains this in the listing, and we'll go through this. And you can see the ground bus bar he put here. He's doing his best to basically use what he learned from my channel, and the reason I know he used my channel is, once again, as we go through this, you'll see how it all ties in. We do have an EMI filter present here for his VFD, which of course is a definitive no-no in terms of being mounted inside the electronics enclosure, where essentially we're surrounding this USB board with not one, not two, but essentially 3 power supplies, and the largest one being the VFD, which emits the largest amount of EMI. Now, is it me saying this? I have a lot of questions on this. Or am I just, regurgitating, garbage? Well, I'm going to show you definitive proof about what he did here in terms of the stability potential issues we're going to have. And this is direct from HY's user's manual. Okay, guys, in this portion, I want you guys to have a point of reference direct from the UC100 USB motion controller manufacturer, and that is CNC Drive. This is their lead engineer, Balasas. I hope I'm saying his name correctly. If I'm not, I certainly mean no disrespect. He said, Vince, there can be 3 possible causes for a dropping of connection. And he's speaking about the UC100. Now, what I want to point out is he gives us, and you guys can stop the video and read this yourself, he gives us actually 3 highlighted points of what would cause this. And again, the first one, of course, is the USB suspend function in Windows Power Management. That's pretty basic. Over here, he says a computer issue. That's also pretty basic. You guys can read that. But I want you to look at ground noise problems. Look at the paragraph size of this. This issue is basically that the control system generates too much EMI noise and noise affecting the computer's ground, and so the USB port and the UC100. Mostly the problem happens when the spindle is switched on and off. Another high-powered device is switching on and off, sucking a large amount of current quickly, causing voltage level change on the grounding of the system. Now, once again, guys, I'm not saying this. This is the lead engineer for CNC drive. You can see it right here. This is another source. So now I'm saying it, and I'm also bringing this to your attention. I'm showing you the controller that has the VFD literally probably 2 inches, 2 to 3 inches from the actual controller using a USB motion controller. And it says here, if you read this, most of the proper, he already covered that. The ground point is the same for the computer and the control box, and he's usually connected also to the neutral, so this noise gets also to the computer. If the voltage potential changes fast enough and the amplitude is large enough, it can cause a USB communication error because USB is ground reference, which means the PC ground and the UC100 ground is the same grounding point. So when the computer gets the voltage spike on the grounding, and so the ground potential changes, then the UC100 ground potential also changes. But if this changes fast, then the UC100 ground point voltage level change could be lagging behind. The UC100 ground point can't change that fast because the 2 ground points are connected with a USB cable, and the cable has a resistance and inductance, and this will limit the rate of change of the voltage. For my guys out there that want to get scientific, we can do that. If you want to know in simplistic terms what I've said to you, EMI is the #1 cause USB leads to stability issues. And to prove that again, so if the 2 ground potential shifts enough, then the communication will no more work because the data wire's voltage levels are referenced to the ground, which the grounds are then on different voltage levels, so the data becomes corrupted. And if the voltage shift becomes high enough, could even cause the USB chips of the computer to totally give up because it detects the overvoltages. Over here, the solution for this problem can be to use more thick and shorter USB cable and to make a thick and shortest possible single wire connection between the PC ground chassis and the UC100 ground pin. And again, I've discussed this with other clients if they were having issues with that controller, because it's notably a reference point that these USB motion controllers do have potential for these issues. Of course, the better solution is to eliminate the noise at its source, but that is mostly hard to achieve. And then he writes over here, and one more thing about this, we also have Ethernet devices, and he's bringing up their UC400, UC300, whatever it is. You have an Ethernet, Smooth Stepper, whichever it may be, or the Pneumatics PLCM E1B, which work with Ethernet connection instead of USB. Ethernet is an isolated communication. I've said this myself, so it works better in electronically noisy industrial environments than USB. So if you're looking for stable, and you're looking for, again, even if I had an Ethernet controller, I still would never recommend installing it in a controller with a VFD. That's regardless. It's not best practice. We wouldn't do it even with the most stable source. The principle here is that what we're seeing done is wrong. Not only is it wrong from me saying it, it's wrong from CNC Drive explaining it, and now we're going to go and I'll look at the HY VFD manual to show you that as well, and you can see exactly what's said there as well. Okay guys, here's another point of reference. Once again, I've covered this in the CNC VFD Grounding User's Manual Overview. I'm going to put a link to this video because I really don't think 773 views is enough to justify understanding exactly what goes into grounding a VFD properly and your system in terms of the VFD and spindle, because I get asked those questions all the time. I will definitely put a link to this video also in the new video's description. But I want you to read, this is HY's User's Manual, and it says here on 2, for control circuit wiring signal line. The signal line should be separately laid in different conduit with the main circuit wire to avoid any possible interference. Now, let's think about that for a minute. Why would they say that? Well, the conduit naturally separates the 2 different leads. They're saying it naturally, like they stated, that it eliminates interference. What do you think will happen with the VFD in the same enclosure, a metal enclosure, as the controller when the electronics are not being shielded other than with that small EMI filter he has on the VFD, hoping that that mitigates all of the EMI enough that it's not going to penetrate and potentially corrupt that USB signal? thinking about that, thinking about the fact that the motor leads going from the back enclosure to the actual controller itself are not being shielded, please use shielded cable with the size. It even specifies, and this is what's interesting because I get told a lot about HY, not, you know, they're Chinese and their manuals or this and that. And what's interesting is this is perfect English, and I don't know how many people are using this, but they should be reviewing it, and it says please use the shielded cable with the size of 0.52 millimeters for signal lines. Use the control terminals on the control panel correctly according to your needs. It then comes down here and explains the entire grounding process. The third grounding method, grounding resistance should be, again, it even is telling you your ohms rating. Be sure to make correct grounding, and it explains explicitly, do avoid sharing grounding wire with other large power equipment such as electric welders, power machines, etc. The grounding wire should be kept away from the power supply wires from large power equipment. Now again, it's really interesting that we see this and we're understanding it, because as we implement building a controller, and I've said this so many times, putting a VFD in direct proximity of your electronics that are sensitive when they're sending and receiving step and direction signals, you're asking for trouble. And I don't understand the premise of it. It's much easier to mount it externally or in its own separate enclosure if those guys want to pursue that. But you can even see up here, please lower the carrier frequency when there's a longer distance between the inverter and the motor, because the higher the carrier frequency is, the bigger the leakage of current of high order harmonics in the cables will be. The leakage current will have an unfavorable effect on the inverter and other equipment. So, I mean, they're giving you everything you need to know. Basically, distance is better, and we always use the double shielded cable for mitigation of EMI. And again, a VFD in close proximity, if they're telling you to use conduit because it's going to protect from signal interference, separating your power leads from your signal leads, what do you think if you put the VFD in the same exact location as the controller? You're really, like I said, you're asking for problems. So again, I hope I've made it very clear that once again, what you do for yourself and what you accept as a reliable system for yourself, that's fine. If you run your system an hour and you say, hey, I've got a reliable system, this is all I need, that's fine. Don't sell something and hope that someone understands what I'm putting in this video. Don't assume that, because many guys don't. Many guys don't read a lot of this type of literature until they find a problem, and that's when it's too late. And that's why I said I hope that they find these videos, at least one of you find these videos, really watches it and tries to learn, because the guys that really want to learn are going to watch it and they will decide for themselves, hey, you know, maybe what he's saying makes sense. You know, he might know something considering he's got 300 videos. He's done over 7,000 sales on eBay. He obviously has some aptitude to work with this, you know, aside from parts and components I've engineered. I mean, just think about that. Just call up and ask. I mean, these are right out of the user's manuals of most of the components we're dealing with. So again, you've got the USB information direct from a USB controller manufacturer, one of the most popular on the market, CNC Drive, and now you have one of the most popular VFD manufacturers in the industry, which is HY, and this is direct from the user's manual. Once again, I'll put this video link in the description, and I hope it helps all of you. Now, we know that this VFD, like many others, are all knockoffs of HY. And the reason I say that is he specifies what brand this is, but we know right now as we look here and we see this braid going around the leads, none of these leads are shielded, none of them. I do not see any ferrites present. I see no means of EMI deterrent going to your motors, so we already know that's a no-no. Using a USB controller, once again, and I've specified this before, USB is a very tricky format to get away with, especially when it's mounted inside a controller, because of the fact it's only relying on a 5-volt signal. Now, this particular board runs on 24 volts. He may decide to bring that up. If he does, that's great, to whoever he goes to sell this to. But the thing is this, the actual USB port itself is relying upon 5 volts. I have yet to see anywhere that a USB would actually take 24 volts. What we do know is that with signal voltages in the 5-volt range, they are very, very susceptible to EMI. When you have large amounts of EMI devices, especially a VFD which produces the largest amount of EMI in our niche, you're going to have huge amounts of problems with stability. Now, as we go through this, we can see here we do have a ferrite present here, and again, this is going over leads going to, I believe, the VFD from what I'm seeing, because these are going directly into the board. So what's interesting here is, and I'm going to let him describe the system, but we already know this is a definitive no-no. Using the ferrite like he's doing, one giant ferrite, wrapping everything, going through with everything. Again, if we're wiring a VFD at all, regardless of it being installed in an enclosure, which I'm not a big fan of because, again, you're really incorporating a lot more money in terms of actually facilitating, doing the wiring properly, doing the enclosure as far as machining. There's more time there, more port required access, fans, everything. It's most likely always going to be cheaper to mount the unit externally on a wall within 8 to 10 feet to mitigate all EMI, just creating that distance. And then on top of that, when you're looking at facilitating building a system, where does this fit practical use in terms of now we have a fan, one single fan installed, and actually to cool not just one, but we have 3 power supplies here. And again, this is the largest one that generates not only the most EMI, but naturally the most heat because it's drawing the most amps. So again, this fan would have to be rated at a very, very high CFM to really even do this system justice for long-term use. Now, as we come through here, we can see that this ferrite, once again, is only incorporated over these leads here. And these leads are, he's trying to filter for the actual leads going to his spindle. Now, as we come over here, and this is really frightening, is he has the VFD wired with 18 gauge wire. And you can see UV and W, which the hookups are basically the same. Any wiring done to a VFD in best practice should always be 16 gauge, and that's to once again withstand the amps that these units always require. So keep that in mind. I've said this many times. I get asked that question a lot. If I'm using an 800 kilowatt spindle, do I still need to use 16 gauge actual wire? And that's a mandatory practice. And again, all of your power leads, as far as going into the system as well as going to the spindle cable, should in best practice be double shielded. That once again mitigates both forms of EMI. If you haven't heard it in this video, you're going to hear it 100 billion other times in the 300 other videos I have posted. This is what it does. So what we have here with 18 gauge wire, he's using silicone leads. Once again, I know he's got that from my channel, and that's great that he's doing that for the flexibility factor. Where he dropped the ball is the fact that he's using an improper gauge for this application. He then comes over here and he wants to show you the software that comes with this controller. It's a Planet CNC controller. He then comes over here, and I guess he's trying to justify the stability of the system by showing you different projects that he's claiming associates with the unit. We have no idea if any of this is true, but what we can do here is now scroll down, and you'll see I removed the seller's information. And what I did here is I wanted to let you read what he wrote. Well, this is a Planet CNC MK3 DRV 4-axis controller. Now, I have no affiliation with this controller. I've never used it. I've never tested it. I don't know anything about it. I'm not going to say it's good or bad. All I'm going to say is we're going to go over the facts of USB. And regardless of the manufacturer, USB, when it comes to anything CNC related, has its good points as far as compatibility, allowing you to use a Windows operating system that once again is not going to be XP, so you'll still be able to use Windows 7, usually 32-bit architecture, 64-bit architecture, all the way up to Windows 11. The issue is that you're only dealing with a 5-volt signal, and that 5-volt signal, once again being at so low in voltage, is easily corruptible. If those signals get corrupted, you can have all kinds of issues, and if you don't believe me, ask anyone who owns a USB controller, and you'll see exactly what I'm talking about, okay? The other thing I want you guys to pay attention to is the VFD. Again, it's a 110 volt fully programmed, and here is why I say I know he watched my videos, because it says wire with 18 gauge stranded silicone wire. All components are grounded to a central grounding bar. He paid great attention to that, and I'm proud he did. The issue is is that naturally when we have a VFD mounted inside the electronics enclosure with a USB controller, you're going to have issues. The other thing he brings over here is he didn't actually wire it for switches. He says with soft limits, I didn't find that necessary. And he then says, I have cut several plaques with this control in some projects as small as a quarter. When set up correctly, this is an extremely accurate machine. Well, the other issue is this, and I brought this up to the potential client. I've said this to many guys. When we talk about accuracy and we talk about stability, based on what time? If he's selling this, we have no idea of how long this system was run, tested, anything. There's no definitive proof on anything. But one thing I do find interesting is if we come over here and we look, replacing a Chinese JP382C board with a genuine Planet CNC MK3 DRV controller. Well, we already know this is the controller he's using. I looked up this article, and it's very interesting, and it's kind of convenient that it actually reflects just basically the same actual controller, again a different unit, all in all different knockoff. What we do notice here is we do have a knob on the front for, I'm assuming this was spindle control, and we see the generic board as far as the driver and as far as the controller. And what they're showing you here is actually coming in, removing this, and I like this, they show you throwing it out, which probably is the best thing you could do just to get the system stable and remove it from being a paperweight. And then it says take your MK3 DRV controller and 3D printed pillars and you're going to install it in this unit. So what he did, and I'm assuming he did, or it would be an extreme coincidence, is that he watched or reviewed this blog, came down here, and then if you look, you can see here that this filler panel is exactly what he has in his unit. We'll come back. We'll go right here. You can see this filler panel is exactly what he had in his unit, and it's really interesting to look at. On this secondary picture you can see the same filler panel being used, so that's how I know it would be basically him winning the lottery to pick that without actually going in and changing that. So we already know that's basically what's happened here. He basically read the article and he did his best to convert to using this board. And again, there's nothing wrong with that. And I think that there's a misconception that when I do these videos, and I get asked this a lot, I get told it a lot in comments, guys will say things like, well, I don't want to show you my system because you'll nitpick it and you'll pick it apart. What you build for yourself is totally up to you. Whatever your competency is, whatever you feel comfortable doing for yourself is something that, again, you're going to take accountability for it either after the build, before the build, or you're going to take accountability when you actually hit the on switch. That's totally up to you, and something that we all at one point as end users have to accept. What I have a problem with, and where I nitpick, so to speak, and where I try to save the unsuspecting novice who's getting involved in this genre with videos like this, is from people who are selling units that truly don't understand what they're selling. And that's the beauty of when we can pull up all this information. The internet has got everything present. So if he read this article, I can find it. You can find it. The question is, will you? Will you find it before you'll drop $800? This potential client that came to me, did he find it before actually presenting that to me? No, I actually sent this to him. I found this, and it's just extremely convenient that this whole process, I mean, they're outlining everything, how to connect it, how to set it up, and there you go. And that's exactly what he came up with. The only issue is that this article doesn't cover anything about shielding any of the motor side of the cables going actually to the rear of the back plate where it would actually connect to the motor cables. None of that's done. Nothing is brought up again about, you know, mounting naturally a USB board inside an enclosure with a VFD less than a couple inches away, because they're assuming that that EMI filter that they have in there is enough, it's strong enough that it's naturally going to mitigate any type of potential interference with that board. That's a big gamble. And it's an extremely big gamble when you think about purchasing something online from someone who's selling one unit and what is their experience with this in terms of if you have a problem, how are you going to rectify that? Once again, if you're building it for yourself, if this gentleman or whoever this is building it for themselves and trying to say, hey, look at what I did this from this article, I corrected everything, that's great. That's a fantastic thing. If he found stability and is able to machine with it and he's comfortable with his investment, that is fantastic. That is the overall goal. Where the problem is when somebody does something because they found an article and is hoping that someone may not be as knowledgeable or maybe aren't looking that far ahead to say, hey, you know, someone may buy this, and if they have problems, how do I handle that? Is he going to be able to replace this entire box? I doubt that. Okay? Looking at the person's feedback, I can tell you it's very low. The odds of that, I highly doubt that. I mean, again, you're only going to buy these controllers typically bundled with another CNC system. So that would require him to do that, change everything, or change components. It's most likely not the case. And most people that are selling used systems, that's what you find. And he, of course, did list this as a used system. So again, I hope I made that clear. I hope I've made clear what you guys are seeing here and with the information in here, once again, from UC CNC, the manufacturer of the UC100 USB motion controller, which once again is a USB controller. This is an integrated controller, also having the drivers on the board as well. That's fine. But the principle is the same for USB. I don't think there's much more we need to say. And then on top of that, of course, I mean, there's not much to say when we see the motor leads coming into the actual board not being properly shielded as they should be. So again, guys, I really hope that these videos are helpful, especially to the guys looking to start a business. I know things right now are crazy. I mean, gas prices are astronomical. If you break the investment down, you know, for a couple $1,000s now, you can easily get yourself into a system and start making money. I hope all of you at one point or another decide to do that, but I hope you take the precautions, and when you start doing your due diligence and doing your research, you really weigh everything accordingly. Ask the right questions. If you need to pay for consultations to get the proper advice, do that first. I've said it before and I'll say it again. You know, a $60 consultation will definitely save you an abundance of money and time if you at least weigh what I'm saying. And again, if you don't believe it, you'll see the information in here from reputable sources, and then you can make your own judgment. And again, that to me is giving you the empowerment to at least know the truth, and then you can work with your budget, because that's all what it is. There's no point in purchasing something and hoping for the best when we know what works, we know what's tried and true. Make sure you guys, I want to make sure you guys understand that overall the whole goal here is to make it so that you're purchasing something that's stable, you'll be able to make money with, get that return on the investment that you're looking to do, and move ahead with whatever business model you plan on going. So again, I can't state it enough. I hope that this video has helped you guys. If you guys actually require consultations, have any questions, wanted a quote on anything, message me direct at storm2313@gmail.com. You can also message me through my eBay store, eDealers Direct. You'll see links in the beginning of the video and at the end. I thank you all for support. Take care.